Okay, so we're doing comparator. Okay, so I started here. Still all haven't joined. You want to all join it, please. Okay, right. So comparators. Right. So here I create a list of integers. Now you can only add items that implement the comparable interface to a tree set. Okay, you can only add items that implement the comparable interface to tree set. So that's all wrappers, strings, string builders, or any of your own classes that implement the comparable interface. For instance, rat. Okay, so we can have a list of rats, but we can't have a list of, so we can have a hash set or tree set of rats. We can't have a tree set of squirrels, all right, because it has to have some way of organizing itself. Only something that is an organized list, that can be in an organized list, can be added to a tree set or can be added as a key in a hash map. Okay, now so that's comparable. Now so that also means you can use collections.sort. Okay, so I can have a list of numbers as I have here, 23, 23, 4, 1, 67, blah, 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 and I call it list num. I can also go like this, collections.sort, and sort the list num. Okay, that will sort the list as well. Now collections.sort only works with lists of items, lists of objects whose class implements the comparable interface. Okay, so I've got that one. Now, so comparator is for usage on lists to order them in a separate way. It's an object that's going to order your list. That's what a comparator is. Okay, comparable is something that's part of the rat class. Okay, so if you have a list of rats, what organizes the rats? The compare to method inside each rat organizes it. A comparator is a separate object that you use to organize your lists. Okay, they both do the same thing. They're just different ways of implementing a certain thing. Now, comparable only objects that implement the comparable interface, they can be put into tree sets or as a key in a hash map. Okay, now a comparator can be used to organize lists. Okay, it can be used to organize lists of any object. Okay, now they can be used to organize a list of objects that also implement the comparable interface. There's nothing stopping them from doing that. Okay, they can also be used, so we can use them to organize a list of rats in a particular way. We can also use them to organize a list of ducks. Now, ducks doesn't implement comparable, but we can use a comparator to organize the ducks. All right. Now, I started doing stuff that was slightly too complex too quickly yesterday, so I'm going to revise the stuff I did yesterday. Is that okay? Right. So I was going a bit too far ahead. I should have done easier stuff first. So we have a list of strings. Okay, here's my list of strings, and I created a comparator for it. Now, the string class does implement the comparable interface. All right, but I've decided I want to order them a different way. Okay, what's the different way I want to order them? seconds. Get this side working. Yeah, control panel. Bear with me a minute. Okay, right. Here's my touch screen working. Now, right. Now, so I have a list here of strings. Now, I have created a comparator here, and it's comparator. So this is an anonymous class implementation of the comparator interface. Okay. Now the comparator is a functional interface. All right. So you can also create lambdas from it. We're not going to quite do lambdas yet. So this is an anonymous class implementation of a comparator. So it goes comparator. You say what type it's going to be. So it's going to be a comparator for a list of strings. Okay. And I call it by string. U comparator string. Now you have to put in the type here on the right hand side as well. Okay. So for the comparator to work, you have to put in string here and string here. If I don't put string on the right hand side, it shouldn't work. Let me just check. No, doesn't work. Okay. Now, so what we're doing is we're overriding the compare method. Now, comparable uses compare to. Comparator uses compare. All right. Now, and also compare takes two items of whatever the type we've defined here. So if we said duck in here, that would be a duck, that would be a duck. If we said dog in here, that would be a dog, that would be a dog. If we say string, so that means it takes two strings. Okay, two strings. Now, just like the compare to, it's the same process. All right, you end up with a minus number, you end up with a 0, or you end up with a plus number. Okay, minus numbers, if you end up with a minus number, that one goes to the start, that one goes after it. Okay, that's the way it works. Okay, so you could say if it's a minus number, it's the status quo. You pass in two strings, and if the resulting calculation results in a minus number, S1 is going to go before S2. Okay, now if it's a 0, they're both the same. Okay, depending on what it is you're doing, they may not be inputted into the tree set, for instance. For the tree set, they won't be put in at all. Now, if it's a minus number, the way it works is if it's a minus number that's produced, S1 is going to go last, S2 is going to go first. Okay? Plus numbers, yes, sorry, shit. Okay, so if it's a minus number, say that again. So S1, S2. So it produces a number. Minus 1, sorry, minus number, might mean minus 1. Say minus 0 or a plus. Now, if it's a minus number, it's a status quo. You get S1, S2. Okay? Now, if it's a 0, they're both the same. If it's a plus, what happens is S2 comes before S1. Okay? Now, by the way, all of this crack we're doing here, you could, instead of using all of these dudes, you could have a database and use SQL to do all this for you. All right, so that's a thing to consider as well. So everything we're doing here with sorting, with using comparable comparator, I could argue the case it's easier to do it in it's called MySQL in SQL. I'd argue the case it's easier to do it in SQL than it is these dudes. Okay, but if you want to use these, you have to know how to use them. Okay, so if we know that minus the first goes before the second, zero they're the same, plus they swap places. Let's compare. Yeah, so minus same, plus swap places, and zero they're the same object, or they're the same. Okay, so take out that. Now, so I create a list of strings. Okay, I create a list of strings. Now we have Bernie and Adam, blah blah blah, so on and so forth. Okay, now I print them out. So it's ex. Which one am I on there? There's ex3. Okay. All right. So I print off the names. So it just prints them off anyway. Bernie, Ann, Adam, Aidan, Bernie, Kira, Siobhan, Mick, Shelley, Laura, Colin. Okay, fine. Now, collections.sort. Collection.sort can only take a list. All right, that's the first thing. Okay, collections.sort only takes lists. That's the first thing. All right. Now it can only take lists of. So this version of collection.sort can only take lists of objects whose class implements the comparable interface. Now names is a list of strings. Strings do implement the comparable interface. Okay. So for instance, I couldn't do collections.sort with a list of Squirtles because Squirtle does not implement the comparable interface, or Ducks. Ducks also does not implement the comparable interface. Okay, so you can only use collections.sort with lists of objects that implement the comparable interface. All right, now that's with that version of collections.sort. So collections.sort, the comparable interface is implemented by the string class, and what it does is it, make sure this is right. It puts capital letters first. Okay, capital letters go first. Now I don't have any numbers. I don't have any symbols. Now later on, I am going to be introducing symbols and numbers. All right, symbols come first. Now what's a symbol? Question mark, exclamation mark, double quotation marks, full stops. They're all symbols. They come before numbers, and capitals come before lowercase. So we get all the capitals. We get Aidan, Anne, Colum, Kira, Laura, Siobhan. Now they're all uppercase. Uppercase A, uppercase A, uppercase C, uppercase C, uppercase L, uppercase S. Then it goes to the lowercase. Okay. Now I defined a comparator for the string class that ignores the case. Okay. So it should be, let's make sure this is right. Well, so collections.sort gives us that. Okay. Collections.sort gives us that. So because it uses the compare to method of the comparable interface. So the compare to method in the string class does capitals first, lowercase second. Okay. Now there is a second type of collections.sort. Okay. There is a second type of collections.sort. The second type of collections.sort, what it does, it takes a list and it takes a comparator. Okay, so collections.sort, there's a second overridden collections.sort that takes two arguments. All right, sorry, this is overloaded. Try and correct it. This is overloaded. So it takes a list and a comparator. Now the comparator, this is a comparator for strings that orders them by in alphabetical order only. Okay, it orders by alphabetical order only. All right, and we can see there it is, Adam. So I ordered. Now, so collections.sort does change the list. Okay, so collections.sort does change the list. It's an important thing to know. So it does change the list, and it changes. So now it's alphabetical. Doesn't care about the case. Adam, Aiden, lowercase n, uppercase n, lowercase Bernie. See, they're the same. Uppercase C, uppercase L, lowercase m, uppercase, lowercase s, uppercase s. Okay, so comparators can be used by lists of items that already implement the comparable interface. Okay, so if you want to order the strings by some other metric, okay, you could order as well by the length of the string, for instance. Okay, you could order by the length of the string. So if you ordered by the length of the string, you have n, n, and then it'll go to maybe column, Mick. So you go Adam, column, Mick. Then it'll go up to the fives. Then it'll go up to 6 if we have any, and then it'll go up to 7 if we have any. Siobhan is the only one that's 7. All right. So comparators can be used with objects that don't implement the comparable interface. They can also be used with objects that do implement the comparable interface. Now, after that yesterday, I went on to ducks, and it was too complicated what I was doing. Okay, it was too complicated too quickly. So what I did is everything to do with ducks, I put it into a separate one. All right, I'm going to cover all this again this evening. All right, so you can delete it if you want, all the duck stuff, but I'm going to stay in static void ex3. So no more ducks for now. Okay, so we're going to go to the Squirtle class. Now, I am going to say public class Squirtle implements comparable. Now, just to show you, if I don't give it a type, if I go add unimplemented methods, the compare to method is an object, but then I have to cast that object to be a Squirtle inside it. All right. So to avoid casting, and it's nearly always preferable to avoid casting if you can at all. All right. So avoid casting if you can at all. The simplest way to avoid casting is implement comparable squirrel. All right, because you're only going to be comparing a squirrel or a subclass of squirrel. All right, so if I go here, add on implemented methods. So now you're comparing to another squirrel, and I'm going to call that squirrel S. Okay, now this is going to be a simple enough squirrel. So the variables of the squirrel class are going to be private string name, private int weight, private int height. And I'm just using ints because they're simpler numbers. All right. Now, I'm only going to compare squirrels by their name. All right. So return name dot compared to, I'm going to say s dot name. Okay. So what that is doing, this is using the compare to method of the string class. Okay, we are only organizing lists of squirrels by their name. Okay, so name is a string, so we are using compare to method of the string class. So we could, if we wanted to, also include the two int variables of weight and height, but I'm not going to bother. All right, so I'm going to make sure all of my squirrels have different names. All right, I'm going to make sure that all of my squirrels have different names. And I'm going to organize squirrels using this method. Now, we're going to have a constructor inside this, so it's public squirrel. It's a name, takes a weight, takes a height. This dot name, equal to name, this dot weight, equal to weight, this dot height is equal to height. And I'm going to have getters and setters for, or just getters for each one of the variables here. I'm going to go to source, generate getters and setters. I don't want a setter. Okay, I don't want to change them. So you can do this, you can turn off the setters. So I only want getters. All right, so generate, make them all public. Now the last thing I'm going to do here is I'm going to create a toString method. And we get a public string to string, and we return duck name is. Plus name. Duck weight is. Weight. Duck height is plus height. Now, The compare to method only compares them by name. But what we're going to do is we're going to create comparators that's going to sort a list of ducks by their weight, and we're going to create a comparator that'll also sort it by its height. All right. So we have got, if we just create a tree set of ducks, it's going to sort them by name. Okay. If I use collections.sort, it's just going to sort it by name. Now, if I have a comparator that sorts, I'm going to create a comparator that's going to sort them by weight. So I'm going to call collections.sort on a list of ducks, and I'm going to send the duck weight comparator to collections.sort. Then that list will be organized by weight. I'm going to do the same for height. I'm going to have a list of ducks, and I'm going to use collections.sort with the list of ducks, and I'm going to have a comparator that works on the height of the ducks. Imagine they're huge. Okay. Now I'm not going to be creating a tree set of ducks. If I was creating a tree set of ducks, then I'd have to make sure that that I have the equals in the hashcode method also implemented. Okay. Actually, it's no harm to put them in. So I'm going to put in generate hashcode and equals. Okay. Right. So that's our duck class done. Okay. Oh, sorry, squirtle. Sound corrected. Squirrel. Okay, squirrel. So squirrel implements comparable. All right, and this should be squirrel. This should also be squirrel. Now, so I'll go back here to examples. Now, so I create a list of squirrels. Okay, so I am going to go, I create the squirrels first. Squirrel. And this is going to be Sammy is equal to new squirrel. It's going to have a name of Sammy. It's going to have a weight of 2.3 or 2 and a height of 3. Next squirrel I'm going to do, this is going to be Sheridan is equal to new squirrel, and this is going to be Sheridan, and this is going to be a weight of 4, height of 2. Another squirrel, this is going to be of Samantha, and going to have a weight of 1 and a height of 5. And the last one, squirrel Sean, the new squirrel, Sean. Sean has a weight of 7 and a height of 1. Now, so I'm going to create a list of squirrels. And I'm going to call it squirrels. and I'm going to go squirrels dot add all arrays dot as list. I'm going to add Sammy, Sheridan, Samantha, and Sean. Now it's an unordered list, so there's going to be just what I just printed off. Unordered. Oops. I'm going to go SQIR-ELS. So now Squirtle name is Sammy, Squirtle weight is 2, Squirtle height is 3, so it just puts them in the order they're there. Okay, now Samantha should be first because S-A-M-A. Okay, followed by Sammy, followed by Sean, followed by Sheridan. Okay, now that's if so. Oh yeah, yeah, because originally I had them as ducks here. Yeah, so I changed that to squirrel. Right now, so put it in here. Squirrels sorted by name uses compare to in squirrel class. Right, so I am going to go collections dot sort, and it's going to go squirrels. Okay, now collections dot sort can only take lists, so this one collections dot sort can only take lists of objects whose classes implement comparable. Okay, squirrel implements comparable, and the compare to method organizes squirrels in a list by names in alphabetical order. Okay, so collections.sort squirrels. Then if I print off squirrels, there it is. Samantha, Sammy, the second one. Third one is Sean, and the last one is Sheridan. Okay, so now we see that they're ordered by their name. Okay, why? Because if I put them into a tree set, they will also be displayed that way. Okay, now the advantages of a tree set over collections.sort is the following, right? I'm going to create another squirtle up here, and I'm going to call this squirrel John 2 is equal to new squirrel. Now it's got the same name, different weight, and a different height. Okay, now if I put in the second squirtle here, we can see now that it sorts them, but it also puts in both Sean's. Okay, now that can be an advantage or a disadvantage. All right, so the difference between a list that we sort and a tree set is that a tree set will remove duplicates, whereas sorting doesn't remove duplicates. Okay, do we understand that? Okay, Now, by the way, if you then wanted to sort both Sean's by their age, that's very tricky to do actually. All right. Let's say I attempt to do it later on, and you can see it's not easy to do. We have two squirrels with the name Sean, and then we want to organize. So if they both have the same name, we want to organize them by age or weight. That's tricky enough to do. All right. We do attempt that. We won't get it this side of Christmas. That's one good thing. So something to look back. First day we're back. Yay! Woohoo! All right. So it doesn't remove duplicates. Okay. So put it in here. In B. Now you may want it that way. Sorting does not remove duplicates. Okay. Duplicate names in this case. Now, so I said C Sean 2. Okay. Now I'm going to comment them out because I don't want duplicates. Okay. So I comment out Sean 2, put in here, insert into squirrels list to see duplicates not removed. Okay. Now, so this is sorting according to the compare to method in the squirrel class. All right. Now, let's say we come along and we don't want to sort it by name. We want to sort it by weight. Okay. We want to sort it by weight. So what we're going to do is we are going to create a comparator. Okay. We are going to create a comparator here. So here we go. So this is comparator. This is going to be squirrel. And it's going to be by squirrel weight. Okay. Is equal to new comparator squirrel. There's the end of the anonymous class. I'll slip it in. And then I just add on implemented methods. So comment is, we have to start the fucking meeting again. So here I go again. Okay, so I will invite you again to another one. Okay, so I've sent that to you. Should have it in 20 seconds or so. Okay, should have it by now. Yeah, so join them, please. Here I go. All right. So, you've all joined by now. Yep, could you join it, please? Yeah, they're both functional interface. Because obviously what I'm leading up to is here we're going to be doing lambdas. Okay, we'll do the anonymous class first because they're easier, I suppose. But in reality, you're going to be using lambdas. That's what you use. Okay, so now, so here we have publicly going to compare squirrel. I'm going to call it squirrel S1 and squirrel S2. Okay, so it knows it's a squirrel because I've said the type here is squirrel. Okay, so I want to use the compare to method of the integer class. So this is going to be by weight. So I'm going to go integer. I'm going to say duck 1 W is equal. Oh, fuck it. What film is it got? Squirrel. Oh, yeah, Up. You see that? It's a Disney film. Very good. Yeah, squirrel. So, squirrel. Integer SQ1 or S1 weight. Okay, S1 weight is equal to S1 dot get weight and integer S2 weight is equal to S2 dot get weight. Okay, now we're assuming that they all have different weights. Okay, as I said, we're going to build it up to if they have the same weight, it's going to do something else. Okay, but here we're assuming that they all have the same weight, so we can say return S1 dot S1 weight dot compare to S2 dot weight S2 weight. Okay, so what's that going to do is that's going to return, if it returns a minus number, S1 is going to go before S2. If it returns 0, they're both going to be the same. If if it returns a plus number, S2 is going to come before S1. Yes? Say that again. 0. Yeah, no, it just puts them in randomly. You can't guarantee the order they'll go in. We are going to do that though. Okay, so put in here. So if this returns a minus number, squirrel 1 comes before squirrel 2. So it's the minus number is still the same. The order they'll put in. Okay. If returns a plus number. Squirrel 2 comes before squirrel 1. If 0, they are the same and can be put in any order, but they will be together in the list. So you could have 1,000 items in the list, but the two squirrels will always be side by side. Do you understand that? Okay. They can be put in any order. You don't know that. So if you have 5 squirrels with the same weight, you're not going to be guaranteed what order the 5 squirrels are within each other, but they'll always be beside each other. Do you understand that? If we have 1,000 squirrels, all right, and if we have 4 squirrels with the same weight of 4, okay, those 4 squirrels are always going to be beside each other. Now I can't guarantee the order, so let's say this is squirrel A, squirrel B, squirrel C, squirrel D. I can't always guarantee it's going to be A, B, C, D. It could be B, A, C, D, or whatever. But they'll always be beside each other. Do you understand that? The way it's currently constructed. Yes? Yeah? Okay. Now that's just the way it's currently constructed. Obviously, we can change those sort of things. So, now we're going to do, we are going to compare our list of squirrels. Now, they all have different weights. We have a look at them up here. So 2, 4, 1, 7. I'm only doing 4 of them. I'm not bothering putting in the second Sean the squirrel. Okay, so if this works the way it should, Samantha should come first, Sammy should come second, Shardon should come third, and Sean should come last. Yes? Yeah, so what is this? This is sorting by weight. Sorts a list by weight of squirrel. Okay, so I'm going to go down. So I'm going to clear my list of squirrels. Because I want to turn it into an unordered list again. So I go squirrels.clear, and then add all my squirrels to it. Sammy, Shardon, Samantha, Sean. Okay. And before the sort, no, it brings us back to the, and it empties it. Sorry, put that, empties the list. Okay, so this is unsorted squirrels, and I'm just going to print off squirrels. Then I'm going to go collections dot sort. Now, see, we've got 2 sorts. Okay, so I'm going to pass it in squirrels, and I'm also going to pass it in comparator, which is this dude here, by squirrel weight. Okay, so this should now go down here, sorted by squirrel weight. So put it down here. And now I'm going to print off squirrels. Oops, spelled that wrong. Right. So Samantha has a weight of 1. Correct. Sammy has a weight of 2. Yep. Sharton has a weight of 4. Yep. The last Squirtle has a weight of 7. So we can see here, this is how we sort by weight. Okay? Now, I'm going to do it for height as well. All right? So I'm going to copy this, bring it down here, and I'm going to say by squirrel height. Okay? And I'm going to change this to S1 dot height. This one here, height, and S1 dot get height, S2 dot get height. Change this to height, and this guy to height. Okay, so this is a comparator that's going to do it by height. So I'm going to do the same thing again. I'm going to go down here. Clear it. I'm going to, and I don't have to do this, just want to show an ordered list. So the list is truly unordered, all right? They're just thrown in. Then I go collections, dot sort. It is squirrels, and it is, I'm going to use this one here, my squirrel height. And then I print it off. So squirrels sorted by height. Put them off here. So height is 1, height is 2, height is 3, height is 5. Okay? Everyone with me so far, yeah? You mean call the compare method? Yeah. So you mean have a comparator that takes a superclass? Generic, you mean to say you're trying to generic. You can, but it's messy, I think. I'd have to think about that, Jason. You'd have to use wildcards, probably. So yeah, so you could have, let's see. Yeah, so that could take a subclass of squirrel, right? Or it could have. Um, oh yeah, yeah. Oh yeah, yeah. I mean, say if you just want to do. You can. Yeah, you can. I'm trying to think how would you do it. Your Squirtle would contain some variable inside it, right? So if your Squirtle contained a variable inside it that says, so if we're set to 1, get height if it's set to 2 by weight. Do you understand what I'm saying? You need some sort of switch inside the squirrel. Yeah, yeah. But. We're getting now. Yep. Mm-hmm. It doesn't make a difference. Well, all that happens is all that happens is when you're clearing it. I'm just starting off again with an unordered list. Okay, so if I didn't clear it, it's sorted by that point. It's sorted by weight, and so it's just putting it back to an unordered list again. That's all I'm doing. It'll be the same thing. You'd still get the same answer. Yeah. So it doesn't matter. Okay. Now, what I'm going to attempt to do is I'm going to attempt to create a more comprehensive comparator. All right. Now, we have a compare to method in the Squirtle class, but what we want to create in here is a comparator that's going to check the name of the Squirtle first. If they've got the same name, then it's going to try and compare them by weight. If they've got the same weight, then it will compare them by height. Right? So we're going to use what we've already have here. All right. Now, so I'm going to start again. So I'm going to go comparator, and it takes a squirrel. Okay, and I'm just going to call it SQR comparator. Okay, that's a squirrel. Is equal to new comparator squirrel. Right. So I want to add an methods. I'm going to call it S1 and S2. Now, so I'm going to go here. If I'm going to say not S1 dot equals S2. Oh, that's the wrong one. Give me a second here. I don't hear. Just give me a minute. Yeah, that's right. If I'm not the same. Yeah, so hold on a minute now. Afterwards, it's out now. Yeah, I have to work this out for a minute now. Just give me a second here. So if they're not the same. Right, yeah. So if they're the same, yeah, sorry, take this out. So if they're the same squirrel, it's going to return 0. Right? That's fine. So if so that's the only circumstance it will return 0. In every other circumstance, it's going to return something different. Yes? Do we understand that? Because I've said in the squirrel class that if they have all the same variables, I'm going to say they're the same. Yeah? So the only circumstance where we're going to have two squirrels, so if a squirrel has the same name, age, and weight, both of them are going to be put in. Yes? Do you understand that? Okay. So if S1 equals S2, it's going to return 0. Okay? So As long as they're not the same squirrel, it'll go down here to this line. If they are the same squirrel, it's going to exit at that point. Yeah. So that means either the name, weight, or height is different. All right. That means either the name, height, or weight is different. So if they're the same, so if I go here, if s1 dot get name dot equals s2 dot get name, so if they're not the same, okay, what I do is I go s1 dot compare to s2. Now I'm using the compare to method of the squirrel class because the compare to method of the squirrel class compares the names. Okay, look at it here. See here? Where am I? Compare to method of the squirrel class compares names. Everyone with me so far, yeah? All right. Now, so if the names aren't different, if the names are the same, we're going to compare on age. So I'm going to go integer age 1 is equal to s1 dot get. It's not age either, it's weight. Integer weight 1 is equal to s1 dot get weight. And integer weight 2 is equal to s2 dot get weight. Now with that done, so if s1 dot if weight 1 dot equals weight 2, so if they're not the same, what do? We get weight 1 dot compare to weight 2. Okay, so if they're not the same weight, we're going to compare the weight. Now, next thing I do, integer. Hold on a minute now. Right, let me just change that a minute. Do you know what? I'm going to abandon this entirely because it's getting too difficult. All right, is that okay? So I'm just going to abandon it, but I will come back to it. So I'm just going to comment it out for now. Okay. Yeah. Yeah, but what I want to do is I want to call the compare methods for weight. I want to use that comparator, right? So that's, I just haven't thought it through right, okay? Because I was trying to do it on the fly here, but I haven't thought of it right? So I will come back to it. I'm just going to abandon it for now, all right? Now, so where am I? Here. Now, so I'm going to create a comparator for our rats. So if I have a look at the rat class, we'll see that the rat has got its own compare to method, okay? And it's fairly comprehensive. It orders them by name then age, then weight. Okay. Now, so let's say we want to do something slightly simpler, right? We just want to compare them by, okay, let me just show you here. So I'm going to go comparator, rat, and I'm going to call this rat by rat is equal to new comparator, rat. Okay, I'm going to implement this method. Now, it doesn't make sense to do this, but just showing you can do it. So you can use the compare to method of the rat class inside here. All right. Now, do you ever want to do this? I can't really think of a situation where you would want to use it, but you can. So R1, R2. So you can go R1 dot compare to R2. Okay. So you can use the compare to methods of the rat class inside here. Now, yes, I can see usage for this. All right. So let's say you're comparing by, so that uses the compare to method of the rat class, which compares the name, the age, and the weight. Yes? Yeah? So this comparator uses this compare to method. Now, let's say there's some other outside metric that has not necessarily inside the rat class that you want to compare to. All right? You can put it in there. So this comparator, you can add something else to it above here. You can filter for something else. It mightn't even be an attribute of the rat class. It might be the, yeah, you can. And you could override compare to a method. But this one here, what you can do is, so what you can do here is you can add additional criteria in here. All right. So this one compares by name, age, and weight. Fine. Okay. Except problem being there is that if you're rat with the same name, age, and weight, they're going to set to be equal. Okay. So could have a situation. Let's say the amount of rats in a place. You want to organize rats, and those that are in large numbers, so they're in a group. Okay, so that means you'd have a static ID. So if there's more than 50 rats, that's called a big group. All right. What I'm trying to say here is, with this comparator, you can compare by name, age, and weight, plus something additional here. Okay. This is a general one for all rats. This is going to be, you can filter for further attributes, further things that the rat can do. All right. So you can put in additional stuff in here. I don't have an example done, unfortunately. Yep. Yeah, you could, yeah. Yeah, yeah. Well, obviously the easiest way to obviously fix that is just to put in an ID for every rat. Okay, that's the easiest way. But yes, you could pull something from a database. Okay, so you could do a little check above it. If they're the same rat, don't do this. If they're not the same rat, do this. So you could do something like this. If um, if they're not equal, if R1 dot equals R2. So if they're not the same, trying to see why isn't that giving me a. That should have given me an error. Now it is. Okay, so if they're not the same rat, you're going to use r1.compare2. All right. After that, you could put in some sort of, I don't know, different metric. Okay. So you can add additional criteria in here if you want to. All right. That's what a comparator really is for. You can add in additional criteria, or if the compare2 method of the rat class is too complex, you just want to organize by weight. You just create a comparator that organizes a list of rats by weight. Yep. 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 So, I'll just go here. So you can add in any additional criteria in here. Now the most obvious one is if. So if they're not the same rat, return here. So if they are the same rat, you could put in some unique characteristic there. Now the easiest way to do that, of course, is to have an ID in the rat class. That's the simplest way. Okay. So this is using comparator. This is a comparator. The compare method uses an existing compare2 method. Is that okay? So a comparator can use an existing compare2 method, and a compare2 method can use an existing compare method. So they can use each other because they both return ints. All right. So compare2 can use compare. Compare can use compare2. All right. Now, so I'm not going to put anything additional in here. Now, I'm not bothered going to do a list of rats. So both, actually I will. So I'll just quickly create a list of rats. Now I'm going to copy and paste them here. So here's my 4 rats. Okay. So Roger, Rachel, Ray, Ray. Okay. And then I'm going to add my 4 rats. And then I'm going to print off my list of rats. So that'll just print them off as they are. Name is Roger, blah, blah, blah. So it just prints them off as they're there. Okay. Now, if I do a collections.sort, on rat list, so sorted by compare to, so it goes Rachel, Ray. Now we've got 2 Rays. Then it goes by weight. Ray, this Ray has a weight of 3. This Ray has a weight of 6, and then it goes to Roger. Okay, so if I go rat list dot clear, add all these rats again. So now it's an unordered list, and then I got say sorted by compare. So I go here, collections dot sort. Fuck yeah. It's going to be rat list, and the comparator is called by rat. It's going to give us the exact same result. Okay. There it is. It is exactly the same all the way across. All right. Now, anonymous inner class is what you can use. Now, but what you're usually going to use is you're usually going to use a lambda. All right. So comparators, put it in here. Comparator is a functional interface. So we usually use a lambda when creating a comparator. Okay, because they're easier, because they're neater, because they're tidier. They're not going to be as big. Okay, so now what I want to do is I am going to sort a list of squirrels. Okay, but we're going to sort it by weight in descending order. Okay, so this one here is this will sort our list of squirrels by weight descending order. All right, so I am going right. So I should do it squirrels by weight to start off with, not in descending order. Okay, this will sort our list of squirrels by weight. Okay, so I am going to go comparator, and I'm going to say squirrel, and I'm going to say by weight, and I'm going to say, so it knows that S1, S2 are both squirrels. So we're implementing the compare method, which takes two objects. What does it take? It takes two squirrels, and it returns an int. Okay, it returns an int. So we can say S1 dot get weight dot, work, hold on a minute now. Right, might as well do it this way. Minus S2 dot right. Now, so this is an alternative to using compare to of the double class. All right, this is the more mathematical version of it. All right, now, so to explain what's going on here, I'll bring up my pen. Right, so if there were integers, we could go s1.getWeight.compare to s2.getWeight, but they're not integers, they're ints. Yes? Right, so this is for when they're ints. When they're ints or when they're any number. So let's say that this has a weight of 4 and this has a weight of 1. Okay, you get 4 minus 1 is equal to 3. All right, and remember what happens with ordering when your number is plus. So S1 will go to the end, S2 will go to the start. All right, so this is S1, this is S2. Okay, so 4, 1, it will be displayed. Can't see it because the fucking thing is after quitting. Sorry. Right. So there we go. Screen share only. This will only be for literally 5 minutes. This is only gonna. So I just want to show you this bit, and then you can go to lunch. I know this stuff is laborious and boring, but we have to get through it. Share. All right. So I will invite, email. So there it's sent. Give it 20-30 seconds. It should be there. Life is a cabaret, my son. Uh, 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 uh. Okay, so quickly add it. Join it quickly there. Did you not? Fuck it. I sent. Did you get it there now, EG? Check it again. You didn't get Andrew. Andrew.Kennedy at. Yeah, try it again. I think that's a sign. Go to lunch. Just fucking do it after lunch. Yeah. No, I'll just stop it. Uh, so I'll stop that video. Huh? Oh, I will.